Hello, in today's lesson we're going to be looking at shapes. So I'm having you start with a warm-up that asks you to write down your thoughts and what you notice about why these shapes may be in the groups that they're in. And so just go ahead and pause your computer for a minute and write down some things that you notice. Like you might write on the left-hand side that you see that there are straight lines, right? So maybe you notice straight lines. Maybe you notice that these are all colored in, right? Colored in solid. It's not a three-dimensional solid, but it looks solid. Ooh, so these all look like two-dimensional shapes, right? 2D. And then you might notice that the shapes on the right, with a circle and an oval are not straight lines, right? So they're curvy. Maybe you notice that there are some straight line segments, but that they're kind of what they look unfinished, right? And this is actually called open. So you might say an open space, right? There's an open space. It's not closed. Also, that this looks like it was made from a string, right? So it looks like maybe it's a one-dimensional measurement, like when you take a string and measure something. And so some of them are colored in, right? Maybe that's what they have in common. But the ones that are colored in are curvy, or they are made up of straight lines and curved lines, right? So these could have straight and curved lines. Straight and curved, let's just say segments. And so what we're going to be doing is we're going to be looking at all of these shapes on the left are called polygons. And they are made up of straight lines and they are closed shapes. And hopefully you are seeing that even though the green, the yellow, and the red are closed, they are not made up of entirely straight lines. Okay, so this is the first starred piece of information that you're writing into your graphing notebook. A polygon is a closed plane figure with sides formed by 3 or more line segments. I'm going to go back to this picture and I'm going to say, doesn't it make sense that if you tried to make a closed shape with only 2 line segments, that it's impossible, right? You need that third line segment to actually close the shape and make it into a polygon. And then I want to point out the difference between the closed and the open. And so this was open because it did not have the third line that closed it. So anytime you can sort of take your pencil and run into, part of a shape, that is open, right? This is an open shape. This, if I try to put my pencil inside, I'm kind of, if you picture this as some kind of a barrier, I can't get into that shape in any way from the outside. Okay, now the other thing I have down here is I want to mention a vertex and a diagonal. So whenever you have a polygon, is kind of like a rectangle, but not, right? I didn't make it so that it's a perfect, that the sides across from each other are not the same length. So this isn't exactly a rectangle, but it is a polygon. And when I draw the polygon, the place where the 2 line segments meet at some kind of a corner, that's called a vertex, right? So this is a vertex. And then a diagonal is when you go from one vertex to a vertex across. This is called a diagonal. And it totally makes sense why they're calling it a diagonal, right? Because it's not a straight up and down line. It's not a sideways line. It goes at an angle, right? So that's what's called a diagonal. And you can have a diagonal in other shapes, like I can draw a diagonal across this trapezoid. I can draw a diagonal across this, let's see how many sides, hexagon. And so a diagonal isn't just for rectangles and squares, it's for other polygons as well. Okay, so the next thing I want you to write down has a red star next to it. You classify a polygon by the number of sides and interior angles it has. But I want to point out that the number of sides is equal to the number of angles, right? Those are the same. If I have a triangle, so you know this is a triangle. A triangle has exactly 3 sides, 1, 2, 3, but it also has exactly 3 angles. And the way I denote the angle in a polygon is I draw this little arc inside to show you that I'm talking about the angle that is between these two lines. Like if I extended my triangle and the lines went on forever, this is the angle in between those two lines. Okay, so I also think it's important that you know that a polygon, if you just look at the word itself, poly means many and gon means angles. So when you hear the word polygon, most people are thinking about it's a many-sided shape. It actually means it's a shape with many angles. And the word lateral is sides. And so when you see people talk about a quadrilateral, that's all one word, quadrilateral, this means a shape with 4 sides. Poly means many. So I could talk about a shape that's a polylateral, but nobody really talks about that kind of a word. Polylateral is a shape with many sides. So polygon means many angles, and lateral is the side part. Okay, so now I just want you to see, hey, do you know the names for all of these things? So why don't you pause this video and see if you can remember the names for a 3-sided shape, 4, 5, 6, right, all the way up to 10 sides. And then I'm just going to show you the names. Okay, so we've got a triangle. Tri is the prefix for 3. We've got a quadrilateral. That is a quad is a prefix for 4, right? If you've ever ridden a quad motorbike, it has 4 wheels. And then a 5-sided shape is a pentagon. You might think of the building that's in Washington, D.C. And 6 sides is a hexagon. Hex is the prefix for 6. And a 7-sided figure is called a heptagon. And again, hepta stands for 7. And then you're all familiar with stop signs, right? Which is an octagon. And an octopus also has 8 legs, and octa means 8. And then we have a nonagon for a 9-sided shape. And the last one is a decagon, right? Deca stands for 10. There's 10 years in a decade. So one of the ways that you can remember these words is to remember that the prefixes, right? And so you'll notice that the only words, the triangle and quadrilateral, are the only ones that don't end in gon. And if you have an n-sided shape, if you can believe it, usually people abbreviate it as an n-gon, right? So n is some unknown number. An n-sided shape would be an n-gon. Okay. All right, next. So now we have this idea of some polygons are regular. And so a regular polygon is a shape that has all sides congruent and all angles congruent. And congruent is just a fancy word in geometry, right? So when we, instead of using equal, right, in geometry, because if you're drawing 2 triangles, it's impossible that they can be actually equal to each other because they're not the same triangle. They're different, but the same size. So just remember that when we're dealing with geometry, whenever you see the word congruent, it just means that they are the same value, same size, same length. And so we've got some names of regular polygons, which means all of the sides are the same and all of the angles are the same. So notice, for instance, when I start looking at the at the angles, come on, Ben, the angles that are inside this hexagon, right? Okay, notice I just drew 1, 2, 3, 4, 5, 6 angles, and there's 1, 2, 3, 4, 5, 6 sides. So however many sides you have, that's how many angles you're going to have inside. So now let's look at the names for regular polygons. Maybe you've heard of this before, equilateral triangle, right? Equal means it's the same, and lateral is the sides. That means all sides are the same. And then for, well, this is a fancy, rectangle. I'm sure if I use the word perfect, you know exactly what it is. It's a square, right? And we talked about perfect squared numbers. And then if we have a regular pentagon, notice that it's not really a fancy word. They just put the word regular in front of it. So maybe that's the same thing that they're going to do with the hexagon. Let's see, there we go, a regular hexagon. So notice that a triangle has a special word, equilateral, and a rectangle has a special word, square. But when you start getting into shapes that have 5, 6, 7, 8 sides, they just put the word regular in front of it, and then you name the shape. And notice the next thing I'm going to talk about is called symmetry. And maybe you have heard of symmetry in art. You use symmetry a lot. And the idea is that in symmetry, it's when a line or fold shows a mirror image, right? So my question to you is, do all polygons have symmetry? So if I create a line down this pentagon, and if I put it right in the middle, notice that when I look at the left side and the right side, they are mirror images of each other. Now for a square, I could do a line of symmetry, could go across, it could go at a diagonal. So why don't we do a line of symmetry on this square? Ooh, wait a minute. So if I notice it's a mirror image, but notice this mirror image is along the diagonal. It's not the left and right, but it still shows symmetry. Interesting. So this I would call the left and the right. Maybe. This would be the left and the right. This could be the top and the bottom, but it's definitely a mirror image. Okay, so do you think all polygons have symmetry? Let's go back to the other slide. Ooh, wait a minute. If I draw a line across this, let's pick the heptagon and go across. Oh boy, that is definitely not a mirror image. If I use this quadrilateral and I draw across and I make the diagonal, definitely not a mirror image. What if let's see, maybe if I try to do the same thing I did for the other one, does it look like, oh no, okay, so I can see that this bottom half is bigger than the top half. So I'm kind of starting to see that not all polygons have symmetry, and I think it has mostly to do with this idea here, that if it's a regular polygon, it will have symmetry. There will be a place that you can draw a line down the center and make a mirror image. Only happens with regular polygons. Notice this was definitely an irregular shape. This is an irregular shape, and so whenever you have an irregular polygon, you will not be able to find a line of symmetry. Okay, next. I want you to write this down. Trapezoid. It's a quadrilateral with exactly one pair of parallel sides. Now I'm going to draw something that you will see later, probably a little more next year. But when I do this little arrow, right? So I'm showing you an arrow, and I'm showing you that the bottom of the trapezoid is parallel to the top. Even though it looks like it, when I draw these little arrow symbols, then that is a guarantee that those two sides are parallel. Notice the left side and the right side are not at the same slant. They are not parallel. Trapezoid has only one pair of parallel sides, and we call them the bases, and you'll learn that a little bit later, but they are called the bases. So this is a base. I'll just take that S off. And this bottom is also a base. Now parallelograms, they are quadrilaterals where both pairs of opposite sides are parallel. So they actually have a parallel side here, and then what I'm going to do is I'm going to put two arrows to show you that these two sides are different, but the left side and the right side are parallel, and the top and the bottom are parallel. That is a parallelogram, and this is a trapezoid. Okay. So next, there are some special parallelograms. Well, you already know what a rectangle is, right? It has the length and the width are different. And a rhombus is a little more like a square, but a rhombus is a parallelogram. It just turns out that it has 4 equal sides, right? Remember that fancy math word means it's the same length. So when I say congruent, it means it's the same size. And then notice that a square has all four right angles like a rectangle, but then the four sides are all congruent. So those are special parallelograms. And then here is a special type of quadrilateral. It is a kite, right? Please don't confuse a kite with a parallelogram or a trapezoid. These marks that you see here are congruent marks. It's not arrows. This dash means that this side and this side, right, are the same length. And then the second two sides, the side that goes from AD and CD, AD and CD are congruent, AB and BC are congruent. So it has two pairs of adjacent congruent sides. Adjacent means next to. That means these two sides are next to each other instead of across from each other like a rectangle, right? So let's look at what a rectangle would be. A rectangle would have this side congruent and these sides congruent. So that's your kite. It's a special quadrilateral. So, whoa, this looks kind of crazy, but I want to show you that, you know, with Venn diagrams, you can look at some things that they have in common and things they don't have in common. So notice the whole bigger picture is, I am now talking about every shape that you're going to see that has four sides, right? And so I can make a rectangle. And so under the inside of quadrilaterals are all of these shapes. I'll start off first with parallelograms, right, where it has opposite sides that are parallel. But then a type of parallelogram is a rectangle, and another type of parallelogram is a rhombus. And the square is the special parallelogram because it has the 90-degree angles like a rectangle, and it has the equal sides like a rhombus. And then notice that the trapezoid and the kite, they are not part of the parallelograms, right? They're in their own little set, sort of, you can call it a subset. They are quadrilaterals, but a trapezoid has only one pair of parallel sides, and a kite doesn't have any parallel sides, right? It just talks about sides that are congruent, but there's nothing parallel, right? So nothing is parallel in a kite. All right, and then it says, notice how the trapezoids are not parallelograms. You should know this. The last thing I want you to think about is the irregular shapes. Irregular polygons are shapes with all sides that are not congruent. That means maybe two sides could be congruent, but not all of them. And all of the angles also are not congruent. So there's a triangle, a quadrilateral, a pentagon, a hexagon, and an octagon. Now, the reason it says it's a quadrilateral is because when you start to identify shapes, right, this is the broader category. It has four sides. Then I would look to see, well, is it a parallelogram, right? Does it have any parallel sides? And it doesn't. And it's not a kite, right? And it's not a trapezoid. So that's why it's just called a quadrilateral. Okay, so now I want you to see this. Two of the polygons are called concave, right? And then the other three are convex. And I want you to find if you can see two polygons that have some similarities and then three that also have similarities to each other. And you might want to pause this for a minute and just think about it. I'm going to show you that these first three polygons are the polygons that are convex. So these are convex. And then these two polygons are concave. And what you might have noticed is in a convex polygon, the idea is if I draw a line from one vertex to another, it stays inside the shape. Another way to look at it is every one of these vertexes, when I pluralize vertex, it's called vertices. Every one of these vertices is like pushing out, right? It's going outward, pushing out. So if I think about something inside trying to get out, the vertices are pushed outward. But for these last two, these are called concave, and these vertices are sort of being pushed inward, right? So it looks like it's being pushed in or collapsed, or you can think of it as a cave because you go into a cave. And what's weird is when I draw a line, and I can draw it anywhere, when I draw a line from vertex to vertex, what? The line is actually outside of the polygon. Notice that doesn't happen when I draw any diagonal from vertex to vertex in all of the convex, right? If I draw from there, if I draw from here, if I draw across here, every single one of those diagonals that I'm drawing is inside the polygon, and that's convex. But for these two shapes at the bottom, if I connect a vertex, now obviously I can connect vertices that will be inside, but if I can make any vertices where I connect the two vertices and my line is outside of the shape, it's considered concave. Okay, that is your intro to polygons. Have a great day.